We are here today for another session of community conversations. This is our Technomatics virtual user group today. And our topic is conveyor modeling, so advanced configuration and analysis. As you may know, our speaker for today is Mr. Steffen Bangsow. He works as a freelance simulation expert and has been for quite some time. He's done hundreds of projects and training sessions, and quite a few for us here at Siemens. He's also published 5 books on plant simulation, and he's one of the leading contributors to our Siemens PLM community. So the big steps for today for the agenda, he's going to show you how to configure booking points for conveyor control, to apply MU distance types for accurate movement logic, and then model accumulating and non-accumulating conveyors. So we'll go through those things. He'll go through those live, and then, as I said, we'll do a Q&A. Definitely feel free to raise your hand to ask any questions that you may have. That is the end of my introduction. So Steffen, feel free to steal the screen.
Hello to our next session. Yeah, my next book will be published on November 13. It's then only 3D and updated until version 2504. So will be soon. Okay, our today's topic is conveyor, and this is a quite basic topic, how to use a conveyor, but there are some points difficult, and there are some changes between 2D and 3D, and I selected some topics for this 30 minutes, and the first topic is booking points. Okay, I make one big presentation here. A very simple example. I have source and I have 2 conveyors. And a train. And one conveyor should be fast. This one, I keep it at 1 meter per second. And the second one is slow. .25. It could also be faster. You have such configurations if you need to adjust the distance between the MUs on conveyors, and so you have some acceleration or deceleration conveyors, and so you can adjust the distance between 2 MUs. So the booking point now determines the point where the MU is booked on the next conveyor. In our case here, it's when starts the deceleration of the MU. Now it's at 0.5 at 50% of the length of the MU. And you can set this in the MU itself. I guess you have seen this already. It's a booking point here. You have different conveying directions, so you have different booking points. You don't have now a conveying direction for a vertical movement, but you have already a booking point for the height. Otherwise, the booking point length it's important for forward and backward movements, and for lateral movements, it's the booking point width. And this is percent. Now it's set on 50% of the part, and now the part needs to go until the half of its length on the old with the old speed, and then it starts with the new speed. And for each topic here in the conveyor, you need have to look at the technical realization of the conveyor, and there you need to check when starts the acceleration of this part. If the acceleration starts immediately after the front hits the second conveyor, then you need to change the booking point to 0. And now the acceleration starts directly. The deceleration starts directly if it hits the second conveyor. And this may have influence on the distance of the two elements after. And the next is 100%. Then the mu starts fast, and after it's complete on the second conveyor, then it starts with the slower movement. And this you set here with the booking point. The next influence on the booking of the booking point is how you can access this mu here, because this mu can be booked only on one of these two conveyors. And now I have set it back to 0.5, and you can access this part on this conveyor. If I look here in the attributes and methods, then I can see, okay, cont, here is this part 2. Yeah, this part is still booked on this conveyor, and so I see here num_mu. The number of MUs on this conveyor is still 1. And on this conveyor, the num_mu is also 1. And so plan simulation needs to decide, okay, from which point on this mu need to be booked on, or shown, or booked, or statistically shown on this conveyor. And otherwise you would count it twice if you don't have such a point. So num_mu is also 1. So, but num_mu parts is 2, because num_mu parts this counts every part on this. If you only have one tip on this conveyor, then it counts already with num_mu parts, and you can access this mu also with mu part. Mu part. And so I have here 2 MUs, and you can access with mu part both of these parts. And this is important. This you need to keep in mind. You can book this this object only on one conveyor, and the time it will be booked on the first, on the second conveyor is depend on the booking point. There's no reference point anymore in 3D. So you cannot change the animation here easily because you don't have animation structures and reference lines here on this in 3D. Okay. Next basic setting is accumulating and non-accumulating conveyors. I can make it here. I can make a new one. Okay, next important setting is this is one question we have to deal in our daily work. What kind of blend simulation object I use for a certain part of equipment in reality? With the conveyors, you have one important thing of the conveyor for the conveyor is the conveyor has at each part on the conveyor the same speed. You can stop and start a conveyor and slow down and accelerate, but this affects the complete conveyor of the complete length. And this is the difference between a track and a conveyor. On the track, you can have transporters with different speeds, and you can hit each other. This you cannot do with a conveyor. If you move a transporter on the conveyor, then the transporter is inactive, and the conveyor will transport the transporter like MU. So the speed is on the same at each part of the conveyor. But if you have a look in the technique in your companies, then you have different kind of conveyors. For instance, you have conveyors, chain conveyors, where you have chain and hooks, and you can place parts only in a certain distance. And if you have a problem or a jam, then the complete conveyor stops. And then you have other type of conveyors, for instance, belt conveyors or roller conveyors, where you can use the conveyor itself as a storage. If you have a problem, then you have, for instance, a stopper, and the parts moving on change the distance. And this is one very important setting. This is accumulating. I set distance here of 10 seconds. It's quite easy to check. You have here 1, 2, 3, and now I stop the entrance. I lock the entrance of the train, and this kind of conveyor is accumulating. You can the distance between the MUs can change, and if you remove the lock or the stopper, if you open the stopper again, then it moves out of the conveyor. If you have a chain conveyor, then it's not accumulating. I make more. So, and if I now stop the entrance, lock the entrance, then the complete conveyor belt is stopping. The parts cannot move, cannot change the distance in between. And so you have another behavior. You cannot use this kind of conveyor as a storage. What you need to do, what you need to use for your case, you need to for this you need to check the technique, the technical specification of the conveyor, and yes, and you have conveyor where you have a fixed distance between the MUs, and you have conveyor where you can change the the distance. So next setting here down is MU distance type, sometimes confusing. MU distance type gap, there is gap and pitch. Gap is between the rear and the front, and pitch is between front and front of two MUs. For instance, if I set a gap from 0, then I change this to uniform distributed between 2 seconds and 5 seconds. So now plan simulation tries to secure the gap between two MUs. And so if I set a gap of 0, then only the next part that is moved to the conveyor secures the gap, and so it moves in this way. The problem is if I lock here this source, then it doesn't move forward because the next MU will secure the gap, and so it stops. If you don't want to have this kind of behavior, if it should run forward, also if the source doesn't deliver any MUs anymore, then you need to select another type of distance, and this would be minimum gap. Minimum gap, for instance, 0.2 meters. This means you have a minimum gap between two parts, but the gap could also be greater. And so if I change this to 0.5 and 2 to make a little pressure here. So you have here the regular gap of 20 centimeters, but it could also be bigger. And so it's if I stop the source, then the conveyor is able to transport the parts out of this conveyor. With gap, this is not possible. And there's a third, it's new, I guess, with 2504. This is multiple gap and multiple pitch. And in this way, you can model, for instance, chain conveyor, where you have a chain, a hook every maybe, or you can model pitch. You have a pitch of 1 meter, and if there is no part on at this pitch here, then you have empty places in the chain. So I removed failed, and this is multiple pitch yet. You see, it's the same distance. Here is one part missing, and this hook for the chain conveyor, or if you have overhead power and free conveyor, then this place is empty. But the pitch is here. You have a regular pitch, and this places will be empty. So you have a lot of possibilities. So here's some problem now. I need to create a new one. And there's a new element. So I set again here uniform between 1 and 4 seconds. I want to have a minimum gap of 0.2. And I want to check this here, enforce mu distance. You have two different behaviors. If you lock the conveyor, okay, now I lock the entrance of this conveyor, and this is an accumulating conveyor, and so the MUs are piling up, but there's no distance between these MUs, and sometimes you need to have a distance in this pile between two MUs, and this is new. I don't know if it's 2404 or 2504. Now we have a checkbox, enforce MU distance. Okay, let's have a look. Same stuff. So now I want to enforce this distance. They should go completely on each other. They should keep their distance of 0.2. So I lock. So I lock the entrance of the train, and you see it's still piling up, but not directly part on part. It's now keeping a distance between these MUs. And so you have already a lot of different ways to configure this conveyor and build interesting stuff. Okay. One little thing for programming, you can also change the distance type dynamically. And I have a use case for this. I have a conveyor. I have a station. Oh, I need more space. No. So, and I want to use conveyor as a store. I have source and the train. I set availability and this station. Forty seconds MTDR. And 10 seconds distance from the source. Okay. Conveyor 6, conveyor 5. What I want to model is if there's a failure, if this station is failed, then the MUs should move to this conveyor and pile up there. And if here at the station exit if there is some parts on conveyor 6 and no parts on conveyor 5. This part should go out from this conveyor and go inside the machine. What we need is the same behavior I showed you here. I need for piling up, I need a gap here, a gap of 0. Then it piles up. And then for go out, I need to switch the conveyor to backwards. And then I need a minimum gap. And minimum gap -1. And then it's able to run out of this conveyor. So I need some some controls for this. I need the exit control here. Wrong. I need exit control. I have two cases. One is station is operational and station empty. I need to wait for this condition, or the station is failed. And if the station is failed, I've connected station, so I can use add move to go to the station. And then I need to look. This is conveyor 6. Conveyor backwards false. And then MU distance type. MU distance type. MU distance type is gap. And conveyor 6 MU distance should be 0. And then I move the part to conveyor 6. Okay, I can check this. Let it run. Okay, I need a failure. I guess the exit control is not active. Yes. Okay, it's working. Not found the right time. Okay, it's working. And now I need a control to release these parts from this store. And I need two controls for this. I need the exit control, for instance, to pull the parts from this conveyor 6. I can use an exit control rear to do this. Then I set conveyor 6 to backwards to true, and I need to change the MU distance type. To minimum gap. I don't need and move. But we need a control in the conveyor, backward exit control, to move the part to the station. And so we need another control here. For instance, wait until the station must be empty and operation. And then I move the part to the station. And that's all. And now the buffer should work. Need to set here a breakpoint. I guess I need to change the okay, should work, but doesn't move. Okay, I'll show my cheat version. I'm short on time again. So same programming. Doesn't work anymore. So bad. I will repair it. Two more things. If you have different directions of conveyors and you try to move from one conveyor to another, then you get problems until, I guess, 2404, because it tries to move the tip here of the MU to the next conveyor and then move it back and forward, back, forward, back, forward, and your simulation keep stucking. and they have made some workaround here in 2504. It doesn't get stuck, but you cannot move parts from forward conveyor to a backward conveyor. It doesn't work. It works if you have a backward conveyor and a forward conveyor, and if you move the part with move and then 0, and this works. Okay, it's too fast. So here you have backward conveyor and forward conveyor, and it works. This doesn't work. Also, if you try to move it to a conveyor length to the end of this conveyor. So plan simulation has another strategy to model different directions. Normally, you build up a conveyor system only in forward direction, and then you have several elements to change the conveying direction. For instance, here, this turn plate. The turn plate can change the conveying direction, but only in 90 degrees steps. Like here, you have a long part, then you have a buffer, for instance, where you buffer the parts lateral, and so it needs an element to turn this part and change the conveying direction. And here you can use the turn plate. And the turn plate changes the conveying direction of the MU. It's first is conveying direction 0, and at the end, it's conveying direction 3, lateral left. And so you can again use a turn plate to turn it back to conveying direction 0. You cannot change the conveying direction by yourself on a length-oriented object. It's not possible. You need to use a point-oriented object, like a buffer or a station, to change the conveying direction. If it takes time, then you have here the turn plate to turn it, or you have the turntable to turn it, but turntable has normally an exit in a different direction. And you can use the angular converter here. This thing here, the angular converter also changes the conveying direction of the part. But plan simulation normally don't change the animation here on the conveyor. Also, if you have a backwards movement here, if you have to turn it 180 degrees, I can change this here. Change is 180. Then it still moves forward, and only the conveying direction is changed. And so we can connect the parts in forward direction with connectors without changing the direction of the conveyor itself. Yes. So you have several elements to change the conveying direction. And in the meantime, plan simulation or Siemens don't success to change the conveying direction by yourself. And so you have, I guess, you have the conveying direction of the transporter. It's not here anymore. Here in the main dialog of the transporter, it's missing. You cannot change this directly. The transporter has itself conveying direction as an attribute, but you cannot change it. You can change it with SimTalk, yes. And so it's here in the conveyor system. it's safer and is more stable if you change the conveying direction using the elements blend simulation supports. Okay. Any questions? I fixed this here. It's running to until 1 hour. It's running. I need to fix this. Okay. Any questions? Yeah, move versus transfer. There's several ways to move parts on onto a conveyor. 3 different. There's the commands move, transfer, and insert. Move. If you have move, then it moves only the first tip of the MU onto the conveyor, and the back of the MU will be on the previous block you have. And then it moves the part with this speed until the MU is completely on the conveyor. If you have, for instance, a crane and you need to move a part mid on the conveyor, then maybe you get problems if you try to use move. You can move it on a certain position on the conveyor, but it's better to use insert in this case, because insert books the MU completely with front and rear on the conveyor. And transfer books the part with the front on the conveyor. And so if you move parts with a crane, with a gantry on a conveyor, then it's better to use insert instead of move. Okay, I could talk days about conveyors because it's so complicated in reality. You have so many different kinds of conveyors, and you can change the appearance of the conveyor. I guess you know in 3D properties appearance, you can select here the types of conveyors. Yes, conveyor systems can be very, very complex. If you have several layers, levels, then you need lifts and so on. Yes, it's only the basic conveyor here in this small webinar.
It looks like there was a second question.
Yes, conveyor stopped, true versus conveyor speed. Which way is better? The result is the same. You can also stop single MUs on the conveyor with MU stopped true. It depends if you have any acceleration on the conveyor. If you have a belt conveyor, rubber belt conveyor, then maybe you need to consider acceleration and deceleration, because you cannot stop immediately. And if you need to take acceleration and deceleration into account, then you need to set stop speed to 0, and then it slows down and stops. If you stop the conveyor with stop true, then there's no deceleration, acceleration. And so you need to look really at the technical specification if you need to take acceleration and deceleration into account. So it's not better way. It's you need to check the technical specification. But there are some. If you have a chain conveyor, then it's or very slow conveyors, then it's the same. You don't have. You don't need to consider acceleration, deceleration, and then you can stop it with stopped. And stopped, you have also if you insert the conveyor into a lockout zone, but it's not your selection. How time-consuming would it be to model a brief example of a built-in sequence but ship in reverse? Let's say a conveyor needs to be filled up or flow from left to right, and then exit or flow right to left into a truck train. The problem is you need to prevent to enter more than the needed MUs into the conveyor, and so you need to program the sequence. Yes, but it's not really time consuming, but not in 5 minutes or 10 minutes. You need an overall control for this. You need to feed the parts into the system, then make your processing, and then move it out, and then you can start the next sequence. And so you need an overall overall control for this. But it's not so difficult. And with the backward movements, you need maybe a control for the conveyor to move the parts if you cannot connect it with connectors. But it's not complicated, no. Okay, I changed my model again, and now it works like it should. I only forgot to set up a failure in the source so that I create gaps for unload the. Okay, like every time, if you have some ideas for new topics like this one for built-in sequence and ship and reverse, then give me a short mail or post it, and then we can include this in our plan for future webinars.
Here we are. I did want to show everybody the next 3 sessions because we'll have 3 sessions in June. So you can see on the screen number 1, it may be most important, you can click that link to get to the plant simulation virtual user group area in the community forums. That's where this recording will be on Friday. And then if you're interested in any of these topics, the first one on June 1st, we will be hosting that webinar live from Realize Live. So that's our customer event, which will be happening in Detroit. So Steffen will be presenting there, and we'll just broadcast it out if you want to join in. And then Wednesday, June 10th, Wednesday, June 24th, those are normal virtual sessions like today. So you can see the topics there: model and program gantry robots, high bay warehouse modeling basics. You can click on any of those links if you want to go ahead and register now, so you get updates on that. So that is there. And also I should say the animation is showing that we suggest that you follow the topic of Plant Simulation Virtual User Group. And that means that you'll get system emails whenever we upload a video recording or when we post registration links, you'll get system emails for that right away. So that's the most sure way to keep up with what's going on for Plant Sim. Other than that, we'll just state the Siemens Accelerator Academy team does have this full comprehensive course on Technomatics plant simulation. That's enough to get you started. If you're just starting out, there's a plant simulation associate certificate, and then a couple of live trainings that you could sign up and pay for as well. So calling that out, click on any of those links if they are of interest. And then we have Realize Live, which, as I mentioned, is our customer event annually. Again, we'll be broadcasting June 1st from Detroit, but there's also Realize Live Europe and Realize Live APAC in India. So if any of those are interesting to you, you can click there to register to get more information. And as I've said for the past few weeks, if you're going to be in Detroit, definitely stop by the community corner. I will be there. Love for you to come and say hi. The other thing here is our little 2-question survey poll. Let me pop that up. And if you could just answer about the session, try to remember to do those. We don't always get to it. And it's just vote out of 5 stars or whatever, how you'd give the session. And then if there's any other notes that you want to leave to the team, you can do that there. And that's all I have for announcements. That is Steffen's contact information, his community profile link there, and then another link to the forums for where the recording will be on Friday. We've got a thumbs up. Well, thank you, Steffen, for this session. As always, very helpful. And for anyone here, we hope to see you in the forums if you're not at Realize Live.
Goodbye.
All right. Thanks, everyone. Bye.